All right, today is the day, and today we're going to take a look at the engine wiring harness. Now, I'm not going to go into complete detail about how to and the steps involved in building wiring harness. You'll see some of that, but this video is going to be a little bit more about why I accomplished or why I went the direction I did. And at the end of the video, I'm going to talk about a group, the Horsepower Academy down in Australia. Anyway, I'll talk to you about the end of the video. Right now, I just want to tell you a little bit of story behind the reason I'm kind of doing this the direction I'm going. When I was young, and I went to 1 year of college and studied automotive, and I realized that they weren't going to take me in the design side, and it was just more of a glorified mechanics course. But I still wanted to be around the automobiles. And so right after that, I got a job in Salt Lake, Utah at Steve Harris Imports. And Steve Harris was the import for Italian cars. He had the Ferrari, Maserati, Fiat, Lancia lines there in that shop. And of course, me being the early mechanic into the shop, the young guy, I got stuck with all the jobs that the flat rate mechanics did not want. And of course, one of those is chasing electrical gremlins. Italian cars were notorious for these kind of problems, things that you just couldn't figure out what was causing the problem. Almost always the ground, but anyway, that's the side point. But one thing I've noticed back then, of course, in the 80s, there's also a problem in general, and that's when the auto manufacturers were having pressure to reach emission standards. And if you open the hood of an 80s car, there was just a spaghetti mess of wiring and vacuum tubes, all these things trying to accomplish new emission standards. And then the car was started to a phase of evolution that was just add this onto it, rather than redesign from the beginning. But anyway, I got to the point where I almost detested working on electrical problems. So when this project, I wanted to make sure that the electrical system was super simple, and more so that I could find problems. And I knew there's going to be problems because 4 things are up against me in this. I have to build the wiring harness from scratch because it's not coming out of an existing automobile, not going into an existing automobile. The engine's fresh rebuild, and I'm using a standalone ECU that is built from a kit. So I've got these things that are kind of stacking up against me that if I even want it to start and run from the beginning, I've got to be meticulously careful about how I put things together. And if I do have problems, like I said, I want to be able to get right to the point and be able to separate systems out and find their problems. So anyway, let's go take a look at what I did to put this wiring harness together, and I'll chat a little bit more about it when we get done. Well, the starting point is a wiring diagram, and I can't say this is actually the starting because this diagram is actually built up as you go. But the trick is you need to go ahead and locate all of the sensors and outputs you're going to need to run the engine and get those placed. And from this schematic, I'm able to create a list. And this list just tells me how many wires that type of sensor needs and how many are going to be going to the firewall. Once we have the list, it's a matter of now arriving at how long that wire needs to be. So, stepping from the list, take each one of those wires and go to the engine with a piece of rope. Run the rope in the location where the wire will go. Here, measuring fuel injector to the output there. Take it over to some kind of measuring device and figure out how long that's going to be. Once you measure your rope off, write it down on your list. Pretty soon you have a complete list of all the lengths that you're needed, and then it's just a matter of going through, cutting your wires to the length as the list describes. I've broken the whole set of wiring harness into 4 different areas. This being the longest run coming off of the differential. Now that I've got those measurements all created, I'm going down the list and starting to cut wire. Now I'm using the same colored wire throughout the harness, and that's because it'd be very expensive to try to buy a spool for every run and have that many different spools of wire. So the trick is when you're using a single colored wire system, you need to label each of the wires at the beginning and at the end. So find yourself a fairly inexpensive printer works just great because you're going to encapsulate this in a clear shrink tubing. And as we labeled each of our sensors, I've given them a number and a location in which part of the harness. Print that up. clip those out and stick them on the wires. Now you'll also notice there's a color banding on that. As I'm narrating this here, you're going to see me now building one of the longer runs to the coils. And the coils require 4 wires. One is the signal from the ECU, one's 12 volts, one's an engine ground, and one is the signal ground. So I have used a red color band to show that it's 12 volt supply, and the green shows that it is an ECU or a signal ground. The other wires being blank, it's easy for me to know where they go to. Showing you there, of course, the 12 volt supply to the coil. Now you see also that changed to a different colored wire after I just told you I'm going to use the same color wire. This red wire is actually just a little loop back on that supply voltage where there's going to be a capacitor added to ground for noise suppression at the coils. So after these wires are all cut, the ends are all cleaned off, I'm going to connect them to the little pigtail connector for the coil that came with the coils. Some connectors you have the middle part of the connector actually at your disposal, but most of the times you're going to have an existing sensor that you have to just cut the leads off and then splice those together. And those are all done with just crimps. So here, crimping the wire, and then I will go ahead and put a heat shrink on to protect those crimps and to hold those crimps rigid from vibration. Almost everywhere on the harness you're going to have a heat shrink over a crimp, and then another heat shrink combining a group of wires to hold them all, again, rigid. The bundle together gives a little more strength and rigidity to keep them from vibration and coming apart. Always a big debate whether to use crimps or soldering, and crimping is the winner in that debate. As I said, each of the individual crimps was heat shrinked. Now you see me putting the black one on there. That's going to heat shrink the whole group together. I have a little heat gun in my soldering station, taking it in there to actually do the heat shrinking. Now doing these narrations, I never know when to show it, when to talk over it. Sometimes you'll just see me just be quiet and let you see what's going on. So after you've made up basically a sub-harness, it's time to combine them all into what we call the full harness. I'm doing this harness with I don't even know what they would call this stuff. It's a expandable nylon mesh tubing, singeing all the ends there just to keep it from unfraying a little more than it does. Now to slide this stuff over, you have to have the ends all sealed over. So I have this tape, and this is a 3M tape. It's kind of like a masking tape, but it's made of plastic. It is incredibly good stuff. It does not stick to itself like a masking tape does. And then this nylon mesh, slide it over the wire bundle. And as you push it, it expands, kind of that Chinese finger torture device, kind of the whole same theory. But we're going to go ahead and use this to sleeve each of the little sub-harnesses together. So in this case, we're looking at the bundle that's going to go alongside the valve cover that supplies the coils and a couple other sensors in the alternator. So the length of this sheathing is just long enough to cover the wires to the point where the next pigtail will be sticking out to supply the next coil, basically. And tied it all off here with capstan tape. This is a high temperature tape. Don't need too much of this, just enough to find the ends as we bring up the next expandable sheathing. Little heat shrink will seal the ends and tie them to the last part of the loom that was placed in before. So now you're working from the point where all these are going to connect together. So you're going to see me now switch and undo some of that tape that I had to put on so that I could fit the expanding sleeve over it. Because I need to find the ends of those wires so that I can match up the next part of the loom to the existing that's underneath this tape. Now that I know where it is, I'm going to just mark it on the tape now so I don't have to do this again. So now I can put my wires right to that mark and then know where it's going to come. Using my scissors here, a little measuring device, go cut me another piece of heat shrink tubing, another piece of expanding mesh. The downfalls of working in a shop and trying to do videos, huh? The compressor, the furnace, something kicks on, you got these horrible noises in the background. Sorry for you. I'll try to keep quiet here. We'll try to narrate over all that. Pretty self-explanatory what's going on here. I'm going to throw some more caps and tape here just to mark my location for the length. Also get a little more control of this bundle of wires. Of course, maybe in a racing application you might be actually twisting all these wires together into a nice and tight loom. We got to cover up those wires. They'd really try to snag on that expanding nylon mesh. Yeah, thanks goodness for that. Some of these wires you see don't quite go to the end where we've been measuring everything to. They are actually going to come out of the loom and go to engine ground. There's an engine ground a little bit before it gets to the termination point. So we'll shrink this up and then move on. I think you get the idea of what's going on here in the making up these looms. Shrink them together. binds all that spanning mesh. So the next step is when these get to the termination point, which is a panel we're going to put together, they're going to connect with multiple connectors so that I can isolate each different sensor. But all those are going to combine into a bulkhead connector that's going to go through the firewall into the cabin. So I'm just tinning the leads and starting to connect these wires that are all pre-cut to that bulkhead connector. This is the 37 pin connector. We're using all but 3 of the spots, so just about perfect for what we needed. Military grade waterproof connector. They insert into little cups, so you pre-tin them, put a little flux on them, and solder them deep into the cup. And that one's done. That's the blue one. That's the one coming from our loom and connecting to the firewall in the engine compartment. Now, once it gets through the bulkhead, the opposite side of that bulkhead connector is this one in yellow. And you'll see here, same thing, 37 wires all pre-cut. But they are going to another type of connector. The DB connector is what comes with the ECU. So we're just going down our list and our schematic, which tell us which pin number is from which sensor. So we can find the pin on that bulkhead connector and then find the matching corresponding number from our chart that we've created from our diagram connected to the DB connector. Okay, now we have our wire harnesses. There's 4 of them. I'll show you those independently in a moment, but here I've created this little aluminum panel that I'm going to attach all these things to. One thing about the aluminum panel, we can just drill some holes and then use some zip ties to tie each of these looms separately to the panel. If I ever need to extract one, just a matter of clipping that zip tie off, pulling that out, and I can access it much easier than having all of these parts of the loom bundled together in a big wad the size of your wrist. And I'm going to go here and explain to you that whole panel system right now. So this is the main distribution point for all the electrical in the engine compartment. And I have mounted it on this aluminum plate as a grounding plane and as sort of a heat sink, in that there'll be a space behind it, air can travel behind it, keep everything cool. Nothing here that's really sensitive to heat, but you might as well keep things as cool as you can just to keep things to last longer. Here we have the relay and fuse panel for the fuel injection system. That is part of the Megasquirt system if you buy that. I purchased that and ended up using the MS3 board, so part of the distribution for fuel injection is actually coming off of that MS board. But here we have power for the board and some other connections for the fuel pump. So that is separate. Keeping that because that gives me an easy access and reference so I can visually see fuses and things like that there. Down here, of course, is the main relay fuse panel that's going to find everything that needs to function on the engine. Things besides the engine that are in the engine compartment will be fed by the CAN bus back to the tail lights and things like that. Another fuse panel here, because there was not enough in that box here. We're just going to mount that into that. And here, of course, is where all the wiring, the looms come in, tied to the board, keep them isolated. And then all these connections will come together. This will be the connector through the bulkhead. And on the other side of that bulkhead, of course, is this part of the loom, which will connect to the ECU. This bulkhead connector supplies all the main power functions to the engine, everything except for the double-aught wire that will come back and feed the starter, alternator, and heavy power use. So let's go ahead and go out and show you where it's going to fit according to where the engine is. As you can see, I have 4 separate looms coming into the panel. And each of those are according to the area where they're going to run down the length of the engine, or where they feed to. So let me just run a little diagram here I've created, show you each of those looms. This is the intake side. It's going to provide the mass flow air sensor and boost control. Then another loom feeds the coils and a couple other sensors, temperature and the alternator. And then we've got the fuel injectors, all the fuel injectors. One goes under the plenum, feeds all the other sensors. And then of course the last little thing is just a single wire, the bus. Right here we have the short one. That's going to lay down to the fuel injectors. The big long one, of course they're kind of stiff right now. But the long one, of course the furthest part away. Going to go under all this stuff, but that furthest one there is O2 sensors, the lambda system. But once those looms feed out across the engine, this will mount to the firewall right about here. Hopefully I'll still have enough room to put my plenum in there. Of course not I will have room. And of course the idea with this panel was to be able to pull the engine entirely with the back subframe and still be able to start the engine off of the vehicle. So if this panel, the 4 bolts come off, then I can take the entire wiring system without having to pull each of the pieces off separately, but it all comes in one unit. Then of course this panel could come off with the engine and could be mounted to anything as you want to test the engine or work on it outside the vehicle. Then of course here we have the other side of the firewall is the ECU and the transmission controller. Like I said, this is the MS3x version of the Megasquirt system. So this, as we showed before, we got the bulkhead connector, and these 2 connectors will come through. These will be located right behind the driver's seat on the other side of the firewall in a, well, I won't say a cool place because it'll be under a panel, but it'll be much cooler than in the engine compartment. All right, so there you have my wiring harness in the system, at least in the engine compartment. There'll be some more electrical, of course, much further on when we start assembling the car. Part of the CAN bus that will take the system back to the taillights, and then of course all the instrumentation and stuff forward into the cabin and up. But one thing I wanted to do when I got into this whole idea of putting myself out there on YouTube was I wanted to be able to promote good things. And one of those is when you come across a vendor that's really helpful and really does a good job, you want to kind of promote them. And now I'm not being paid for this, but I wanted to make sure I get a great shout out. And I'm going to have a link in the description also for Horsepower Academy. Now they're a small group of people down in Australia who have put together a course, or they have a multiple courses being engine rebuilding, wiring fundamentals, and a lot of stuff in the racing world. So if you want the advanced wiring course, suspension setups, things like that, they have all these videos and courses that you can purchase. I highly recommend it. They're super great to work with. Once you buy one of their courses, you're able to go onto the forums, and then you have access to a group of people that really understand what you're doing in fabrication and racing and things like that. So you have access to opening questions to people out there. So like I said, I'll have them in the description below. And of course, as always, great to have you here. Hope you come back again. And please subscribe. If you have friends that like this kind of thing, please share this with them so they can also see what we're doing. And then again, thanks for coming along, and we'll see you again next time.